Okay, so let's begin. This is lesson 27, which is the next to the last lesson in the course. Our last class is on Monday, and we'll go over a practice exam then. If you haven't seen it yet, I'll send everyone and post on Blackboard the departmental practice final exam. But today, the main topic is to learn the technique of integration by substitution. And you know that by the fundamental theorem of calculus, or if you like, by the definition of the indefinite integral, you have the following rule. So the general formula looks a little bit complicated, but as I do examples, it should become a little bit clearer. So if you're integrating something, right, the question is always, how do you find the antiderivative or the indefinite integral? And if somehow you can look at some complicated expression and you see it can be written as the following form: the composition of f with g of x times g prime of x dx, right? So suppose what you're integrating somehow can be seen, you have to see this, it's not going to be given to you, can be seen as something that looks like this. And if we have the indefinite integral, let me write it as the integral of f of u du is capital F of u. So you know how to integrate the function capital F of x, little f of x. This integral is going to be capital F of g of x plus a constant. So this is called the method of substitution. And the idea is you do the following. You have the integral of f of g of x, g prime of x dx. And then you substitute, you introduce a new variable, u equal g of x. And when you do that, of course, you could say that g prime of x, which is dg dx. So this is, you can think of this as, imagine this to be a fraction, g prime of x is times dx is dg. But g is the function u. This is du. So if you think of substituting u equals g of x and g prime of x equals du, this becomes the integral of f of u du, which is capital F of u, and u plus a constant, and u is g of x plus a constant. So this somewhat complicated looking formula is the method of substitution. And the way to understand this is to look at many of examples. So that's what I'm going to do. I'm just going to spend a lot of time now doing examples. Okay. Any questions before I start going through the examples? So let me write the function here. So it says that the integral of f of g of x, g prime of x dx, equals the integral of f of u du, which is capital F of u, where u is g of x. So this is the substitution formula. And I'm actually just going to start going through the homework problems, which hopefully you've tried to do a little bit, and we'll see how they go. So in the homework, we're supposed to do, first of all, 1, 3, and 5. So 1 is the integral of 8x squared plus 1 times 16x dx. 8x plus 1 squared times 16x dx. So if you look at this, you might see that the derivative of 8x squared plus 1 is 16x. So if we let u, that's going to be my function g of x, be equal to 8x squared plus 1, then du, which is g prime of x dx, g prime of x is 16x. This is 16x dx. So when I substitute, 8x squared plus 1 is u, so that's u squared. 16x dx is du. So we're just integrating u squared, which we know is a third u cubed plus a constant, which is a third. What is u? 8x squared plus 1 cubed plus a constant. And that's the answer. Okay. Questions about this? Let's look at number 3. Number 3 is the integral of x over square root of x squared plus 1 dx. Oops, excuse me 1 minute. Okay, sorry, let's get back. Here's a problem to do, an integral to do, using substitution. So we look and see where's the function of that and its derivative. So if we were to let the function u equal g of x be equal to x squared plus 1, then du, which is g prime of x dx, what's the derivative of x squared plus 1? It's 2x dx. Of course, what I have here is just 1x, but I can multiply and divide by 2. I can say, I can write a half times 2, which is just 1. So I could rewrite this like this. And then when I make the substitution, I have a half. The integral of 2x dx is du over the square root of u, which is 1/2 the integral. So 1 over the square root of u, you have to know is u to the power minus a half. And we know how to integrate a power. You add 1. When you add 1 to minus a half, you get plus a half. So this is 1/2 u to the 1/2 over a half plus a constant. A half times 2, these cancel. So this is just square root of u, or the square root of x squared plus 1 plus a constant. And that's the answer.
Professor, I don't get this.
I'm sorry. So which part don't you get? That's the important part of the question.
Oh, the number 3, I don't get it.
Oops. Okay, just 1 second. So this is the problem, right? And we want to solve this problem by substitution. So substitution means we're using this formula. So I have to find something which is going to be, I'm going to substitute u equal g of x. And I need to have a g prime of x. So I see that if I let u equal x squared plus 1, what's the derivative of x squared plus 1? It's 2x. So if u is x squared plus 1, du is g prime of x dx, that's 2x dx. And if I multiply and divide by 2, here I have 2x. So if I substitute, this is 1/2 integral sign. In the numerator, I have 2x dx, that's du. And in the denominator, I have the square root of x squared plus 1. That's the square root of u. So the first step when you substitute is to get from here to here. So before I go on, is there a question of how I got from here to here? That's the important thing. I'm making this substitution. U equal x squared plus 1. And if you ask, how do I know to make that substitution? That is just something you learn. It's a skill that you learn by spending a lot of time trying to solve these problems and looking at the worked examples, either in the text or in these lectures, and seeing what happened, how it worked. But the idea is to find something that you can let be equal to u, where you also have the derivative of u. So x squared plus 1 is u, and the derivative is 2x, and here's my 2x. And once I get this, then there's nothing left to do, because this is just integrating a power of u, and you know how to integrate powers of the variable. You get this right away. But the
So there is another way to do it.
I'm sorry, speak up. It was hard to hear you.
I said, is there another way to do it?
In this case, no.
So we have to substitute it?
Well, if you have another way to do it, that's fine, but I don't know any other way. You know, there's never just one way to solve a problem, but this is one way to do it, and there may be another way, but it's not obvious to me what it is.
All right.
Right. Let's do one more from the homework, number 5. We have the integral of tangent squared x secant squared x dx. And how do we do that? That's the question. So, you always, you have to know things. That is, you certainly have to know what came before in calculus. So one thing that came before is that if you let u equal the tangent of x, the derivative of the tangent is the secant squared. And here you have secant squared x. So if you were to let u be equal to the function tangent of x, then du, which is g prime of x dx, that's going to be secant squared x dx. And what we have here is secant squared x dx. So if we substitute u for tangent of x, this tangent squared x becomes u squared. And secant squared x dx is just du. So with this substitution, u equal the tangent of x, this is just the integral of u squared. Right? So this is, if you like, the hard part of the problem. You have to come up with the idea of what to substitute. So before I go any further, this is the step that you have to understand. And if you didn't come up with this yourself, at least after you see the answer, you should understand why the statement is correct. Okay, well, what is the integral of u squared du? What is this equal to? What is the integral of u squared?
The integral of what? U squared?
Yeah, what is this?
1/3 u to the power 3.
Okay, so this is 1/3 u cubed plus a constant. And u is the tangent of x. You want the answer in terms of x. So this is 1/3 tangent cubed of x plus a constant. That's the answer. And if you differentiate this, you have to get this. So let's check. The derivative with respect to x of 1/3 tangent cubed x plus a constant is 1/3. When you differentiate tangent cubed, you get 3 tangent squared x times the derivative of the tangent, which is secant squared x. And the 3 and the 1/3 cancel, and you get tangent squared x secant squared x. Just what you're supposed to get. So that checks. Right. Questions before I go on? Okay. Next is number 11. So number 11, we have the integral of 1 plus 6x to the 4th power times 6 dx. And when they put in parentheses like this, they're really giving you a big hint about what the substitution should be. So because the derivative of 1 plus 6x is 6. So if you let u, the function g of x that you're going to substitute, be 1 plus 6x, then du is just the derivative of 1 plus 6x, which is 6 dx. So when you substitute, this is 1 plus 6x is u to the 4th, 6 dx is du. So it's just integrating a power. So that's 1/5 u to the 5th plus a constant, which is 1/5, 1 plus 6x to the 4th plus a constant. Oh, sorry, to the 5th plus a constant. And if you differentiate this, you'll see that's exactly what you get. Number 13, we have the integral of the square root of 25 minus x squared times minus 2x dx. And again, if you differentiate 25 minus x squared, you get minus 2x. So it should be pretty clear that you're going to substitute u equals 25 minus x squared, and du will be the derivative of this minus 2x dx. Exactly what we have there. So this becomes the integral of the square root of u du, or the integral of u to the 1/2 du. You add 1 to a half, you get 3/2. So that's u to the 3/2 over 3/2 plus a constant. 1 over 3/2 is 2/3 u to the 25 minus x squared to the 3/2 plus a constant. So that's the answer. And you differentiate this, and you get that. So spend a couple of minutes looking at these two problems, because if you can't follow what's going on and you have a question, this is the time to ask the question, because otherwise you'll never learn this. Right? This is our last real class.
So what do you mean today is the last class?
No, it's the last class when I cover new material. The last class is on Monday, and we'll go over the review exam. Any question? Okay, well.
Professor?
Yes, go ahead.
Yes, what happened to the minus 2x? You said u equal
25 minus x squared. And when you differentiate,
so what about the
So if u is 25 minus x squared, the derivative is minus 2x. So du is minus 2x dx. So this is just du. And this is the square root of u.
Okay.
Right. This is the square root of u.
Yeah, I get that. So you drop the minus 2x?
You don't drop it. Minus 2x dx is equal to du. When I substitute square root of 25 minus x squared becomes square root of u. And minus 2x dx becomes du. So I'm not dropping anything. I'm making a very careful substitution.
Oh, I see.
Let's see. Number 15 is x cubed times x to the fourth plus 3 squared dx. And to solve that, you would say, well, the derivative of x to the fourth plus 3 is 4x cubed. But I don't have 4x cubed, I just have x cubed. But I could rewrite this like this. Let me just put this in this order. X to the fourth plus 3 squared x cubed dx. I would like to have 4x cubed. So if I multiply by 4 and I divide by 4, this is still a correct equation. And now, if I substitute u equal x to the fourth plus 3, that's this, du dx is 4x cubed. So du is 4x cubed dx. That's this. So when I substitute, I get 1/4 u integral of u squared du. And this is much easier than this. Because the integral of u squared is 1/3 u cubed plus a constant. So this is 1/12, 4 times 3. What is u? X to the fourth plus 3 cubed plus a constant. And that's the answer.
Professor, question.
Yes.
Yeah, can you, but it's possible to do it separately?
What do you mean by separately?
Like you have to figure out the integral of x to the power 3 times the integral of x to the power 4.
So that is completely, you would get completely the wrong answer. So as a general rule, so this is important. If you have the product of two functions, f of x, g of x, and you integrate them, this is not the integral of f of x times the integral of g of x. All right?
Oh, okay.
Absolutely not. I mean, if you make that mistake, you'll get every problem wrong.
But what about the plus sign? We can add them,
a plus, right? Here?
Yeah, yes.
Oh, that's fine. We already proved the integral of f of x plus g of x is the integral of f of x plus the integral of g of x. So this is true, but not this. So if you understand the problem I just did, then what I do now will be easy, and if not, not. So the next problem is, this is number 17. The integral of x squared times x cubed minus 1 to the 4th dx. So spend a minute or two and figure out this. I mean, the important thing is to know what to substitute. What do you let u equal to? What function of x? Any suggestions? What should I let u be equal to?
X cubed minus 1.
Yeah, so if you let u equal x cubed minus 1, then du dx is 3x squared.
3x. Yes.
So du is 3x squared dx. So I can multiply and divide this by 3. I can write this as the integral. Let's see, x cubed minus 1 to the 4th, x squared dx. If I divide by 3 and multiply by 3, now this is my du. So this is 1/3. X cubed minus 1 is u. So u to the 4th du. So that's 1/3 u to the 5th over 5 plus a constant. So the answer is 1/15, 3 times 5. X cubed minus 1 to the 5th plus a constant.
It's so easy.
And you can check the derivative of 1/15, x cubed minus 1 to the 5th is 1/15, 5 times x cubed minus 1 to the 4th times the derivative of x cubed minus 1, which is 3x squared. And 5 times 3 is 15, so it cancels the 15. And we get x squared, x cubed minus 1 to the 4th. So it checks. Number 19, we have the integral of t times the square root of t squared plus 2 dt, which I could write as the square root of t squared plus 2 times t dt. And if you want a hint, I would say multiply and divide by 2 and write it like that. So that's a big hint. And once I do that, you should be able to figure out what the next step is. What function of t should we let u be? U is going to be some function of t. What is it?
T squared plus 2.
Okay, so if I let u be equal to t squared plus 2, what is du dt?
2t.
2t. So du is 2t t. And when I plug everything in here, when I substitute, I get 1/2 the integral of square root of t squared plus 2. That's square root of u. And 2t dt is du. So this is 1/2 the integral of u to the 1/2 du. So what is the answer to this problem? What's the integral of u to the 1/2?
Oh, u to the power minus 1/2.
No.
3/2. U to 3/2.
Yes, almost. Times what?
3/2.
It's u, you add 1 to the half, you get u to the 3/2, divide it by 3/2. Or if you like, 1/2 times 2/3 u to the 3/2, which is 1/3, because the 2's cancel. U is t squared plus 2 to the 3/2 plus a constant. So again, spend a few minutes looking at this, because this is hard and you have to somehow make sense of it all. Questions about any of these problems? Yeah. Let me keep going. Number 21 is the integral 5x times the cube root 1 minus x squared dx. Cube root of anything means that anything raised to the power of a third. The derivative of 1 minus x squared is minus 2x. And I don't have minus 2x, I have 5x. Then we bring the 5 outside, 5x dx. But I would like a minus 2 here, so I just multiply and divide by minus 2. Minus 2x divided by minus 2. So all I've done is rewritten this in a nice way. And if I make the substitution, u equal 1 minus x squared, du is minus 2x dx. So when I substitute it, it simplifies hugely. This is minus 5/2, the integral of u to the 1/3 du. And the integral of u to the 1/3 is u to the 4/3 over 4/3, or times 3/4. So this is minus 15 over 8, 1 minus x squared to the 4/3 plus a constant. And if we want to check, The derivative of minus 15/8 1 minus x squared to the 4/3 is minus 15/8 4/3 times 1 minus x squared to the 1/3 times minus 2x. And minus 2 times 4 is minus 8. Cancels that. And 3 into 15 is 5. This is 5x times the cube root of 1 minus x squared. Again, you need to look at this for a minute or two and see if it makes sense. Okay. Questions about this? All right, well. What about this? This is number 23 in the homework. The integral of x over one minus x squared cubed dx. So spend a few minutes and try to figure out what this is. So in this problem, what should we choose u to be?
One minus x squared.
And in that case, what is du?
Minus 2x.
No, du dx is minus 2x. And what is du? you just sort of multiply across the dx, you get minus 2x dx. So I can write this as follows. This is 1 over 1 minus x squared cubed x dx. And I like a minus 2 there, so I have to divide by minus 2. And now this is a correct equation. So this is minus 1/2. This is 1 over u cubed du. Or minus 1/2 the integral of u to the minus 3 du. And what's the integral of u to the minus 3? All right, minus 1/2. What is the integral of u to the minus 3?
U to the power minus 2.
Well, not quite. It's u to the minus 2 over minus 2. So minus times minus is plus. This is 1/4. U to the minus 2, that's 1 over u squared. So this is 1 over 4 times 1 minus x squared squared plus a constant. So that's check. The derivative with respect to x of 1 over 4 times 1 minus x squared squared. This is 1/4 the derivative of 1 minus x squared to the minus 2. So that's when you differentiate this, you get minus 2, 1 minus x squared to the minus 3 times the derivative of 1 minus x squared, which is minus 2x. And the minuses cancel. The 2 times 2 cancels the 4. I get x times 1 minus x squared to the minus 3, or x over 1 minus x squared cubed. Right? I get exactly that back. So this is the correct answer. Right. Questions about this? I mean, the best thing you can do at this point, perhaps, is to take a piece of paper and just write down exactly what I wrote down, making sure you can understand how one gets from one step to the next. Let's go to number 29. Number 29 is the integral of 1 plus 1 over t cubed times 1 over t squared dt. What do we do? What should we let u be? What function of t? Well, again, you have to understand. I mean, you really need to know calculus well to solve these integration problems. The derivative of 1 is 0. The derivative of 1 over t is minus 1 over t squared. That is, if you let u be equal to 1 plus 1 over t, this expression, du dt is what? What's the derivative of this function?
Minus t to the minus square, minus 2.
Exactly. This is 1 plus t to the minus 1. The derivative of 1 is 0. The derivative of t to the minus 1 is minus 1 t to the minus 2, or minus 1 over t squared, which is basically what you have there, except for the minus sign. So this is, I can write this as the integral 1 plus 1 over t cubed. Oh, and then if du dt is minus 1 over t squared, that means that du is minus 1 over t squared dt. So this is 1 over t squared dt. Minus times minus is plus, so minus times minus, I can do that. So when I'm just rewriting this, and now I can see this is minus the integral of u cubed du. And now it's easy. This is minus the integral of u cubed is u to the 4th over 4. So this is minus 1/4 u, 1 plus 1 over t to the 4th power plus a constant. Right? That's the answer. So take a look at this, and if there are questions, please, this is the time to ask. Okay. Let's look at problem 49. We have the integral of pi sine of pi x dx. And you see you have a pi here, which seems strange, but if let u be equal to just pi x, du dx is pi. So du is pi dx. That's what we have here. If I write this in the opposite order, this is the integral sine pi x times pi dx. When I substitute, this becomes the integral of sine of u du. What is the integral of the sine? What is the integral of the sine?
Minus cosine.
Minus cosine. So we get minus cosine u plus c. and u is pi x. So it's just minus the cosine of pi x plus a constant. Suppose we have the integral of 1 over theta squared cosine 1 over theta d theta. Again, you have to see what you can use to substitute. And because the derivative of 1 over theta is minus 1 over theta squared, if you let u be equal to 1 over theta, du d theta is minus, so this is theta to the minus 1. The derivative is minus 1 theta to the minus 2, or minus 1 over theta squared. So this is the integral of the cosine of 1 over theta, 1 over theta squared d theta, right? Du is minus 1 over theta squared d theta. So 1 over theta squared d theta is minus du. This is cosine of u, because u is 1 over theta, and theta squared d theta is minus du. So this is just the integral of the cosine is the sine, minus sine u plus theta. So this is minus the sine of 1 over theta plus c. Questions? Let's look at 57. We have the integral of e to the x squared times 2x dx. And now they're really giving it away, because if you let u equal x squared, the derivative of x squared is 2x. So du is 2x dx. And this just becomes the integral of e to the u du. And the integral of e to the u is e to the u. So this is e to the x squared plus a constant. Questions? Let's look at number 61. This is the integral sine of 2x cosine of 2x dx. Let's see. What do you do? Well, you know the derivative of the sine is the cosine. So if you let u equal the sine of 2x, the derivative of the sine of 2x would be 2 times the cosine of 2x. So du will be 2 cosine 2x dx, which is almost what you have there. If you put a 2 there, then you multiply by a half and it still is equal. And you substitute, you get 1/2 the integral of sine of 2x, which is u, 2 cosine 2x dx is du. So this is just a half. What is the integral of u? A half u squared plus a constant. So we get 1/4, 2 times 2 is 4, u squared sine squared of 2x plus a constant. And that's the answer. All right. Let's look at number 91 in addition 5, which is the integral of x times the square root of x plus 6 dx. And it gives us a hint. It says, use the method in example 5. So you go back to look at example 5, and you see it says, make the following substitution. Suppose you let u equal x plus 6. And in that case, x is equal to u minus 6. So what we get is the integral of x, u minus 6, times the square root of x plus 6, that's the square root of u. And now we don't have to do anything fancy at all. This is the integral of u minus 6. Square root of u is u to the 1/2. Sorry, if you let u equal x minus 6, du dx is 1. So du equals dx. So this is the integral of u times u to the 1/2 is u to the 3/2 minus 6u to the 1/2 du. And now we're just integrating powers of u. The integral of u to the 3/2 is 2/5 u to the 5/2. The integral of u to the 1/2 is 2/3 u to the 3/2 plus a constant. So we get 2/5 x plus 6 to the 5/2 minus 6 times 2/3 is 4, x plus 6 to the 3/2 plus a constant. Right. So here, what we do is make this very simple substitution, u equal x plus 6. So du dx is 1, so du equals dx, and x equals u minus 6. And we're just able to get something we can integrate using the most elementary facts about integrals. U minus 6 times the square root of u. Well, let's just check. So it's hard to integrate, but easy to check. The derivative of 2/5 x plus 6 to the 5/2 minus 4 times x plus 6 to the 3/2 is what? You get 2/5. The derivative of this is 5/2 x plus 6 to the 3/2 minus 4 times 3/2 x plus 6 to the 1/2. This is x plus 6 to the 3/2 minus 6 x plus 6 to the 1/2. If you factor out square root of x plus 6, which is this, you're left with x plus 6 minus 6. So you get x times the square root of x plus 6. And by a miracle, that is correct. So this is the correct answer. Okay, questions? All right, what about number, let's see, 121? So this is find the area of a certain region. It's the integral from 0 to 7 x times the cube root of x plus 1 dx. And it sort of sketches what this looks like. When x is equal to 0, it's 0. When x is equal to 7, this is cube root of 8, which is 2. This function, this is 2 times 14. So this function looks something like this. And we want to find this area. This is y equals, this is the graph of y equals x times the cube root of x plus 1. So how do we find the definite integral? Well, we try to compute the indefinite integral, x times the cube root of x plus 1 dx. And to do that, we might use the same method we just used to substitute u equal x plus 1. So du dx equals 1. So du equals dx. And if u is x plus 1, x is u minus 1. So this is the integral of x, u minus 1, times the cube root of x plus 1 du. So this is u times u to the 1/3 is u to the 4/3 minus u to the 1/3 du. So the integral of u to the 4/3 is 3/7 u to the 7/3. The integral of u to the 1/3 is 3/4 u to the 4/3. So this is 3/7 x plus 1 to the 7/3 minus 3/4 x plus 1 to the 4/3. That's my function, capital F of x. That's the indefinite integral. So by the fundamental theorem of calculus, this is equal to capital F of 7 minus capital F of 0. What is F of 0? When you let x equal 0, you get 3/7 times 1 minus 3/4 times 1. you get this. This is some negative number. If you put this over a common denominator of 28, this is 12 over 28 minus 21 over 28 minus 9 over 28. What is f of 7? That's 3/7. 7 plus 1 is 8. 8 to the 7/3 minus 3/4, 8 to the 4/3. That's 3/7. 8 is 2 cubed, so this is 2 to the 7th minus 3/4 times 2 to the 4th. So that's 3/7 times 128 minus 3/4 times 16. Right. So you take this, and 3/4 times 16 is just minus 12. So it's just this minus this. You get 3 times 128 over 7 minus 12 minus 9 over 28 plus 9 over 28. And whatever is equal to is what it's equal to. All right, well, this is a new technique. We talked about it a little bit on Monday and some more today. And it's the last topic in the syllabus. You'll see when you do the practice final exam that there's always one question that involves a integration by substitution, not as hard as the last couple of problems I just did, but the basic substitutions. And it's something that you should learn how to do. So in terms of what's coming up, the last class is next Monday. I will email to you and post on Blackboard the sample final exam. And that's what we will go over on Monday. And the final exam is a week from today. It starts at 1:30, not at 1 o'clock, and goes for 2 hours. So the final exam is next Wednesday, 1:30 to 3:30. Right. Any questions before we go? I will have probably, so the last class is on Monday. I will have like a review session or office hour type things later this week, probably on Friday. And again, we have class on Monday and maybe also on Tuesday. So there should be a lot of opportunities for you to just get onto Zoom and ask me problems of any sort having to do with calculus. And I am glad to help. You'll get the review sheet today.
Thank you, Professor.
What?
I said thank you.
Yeah.